Welcome back. My name is Andreas Revert. I'm a Microsoft Technical Trainer, and this is the exam prep video series on AZ-305. In this second video, we will review how to design data storage solutions.
Our second group is about how to design a data storage solution. Within this group, we will design a storage solution for relational data, design a storage solution for semi-structured and unstructured data, design data integrations. Let's begin with first topic in this functional group, design data storage solution for relational. Azure Storage and the design you take must first determine what kind of data you want to hold. Relational or structured data is stored in a relational format and has a shared schema. Often, we store it in databases with tables, rows, and columns and keys. For example, medical records, phone book entries, and financial accounts. Semi-structured data is less organized. The data fields do not really fit into tables, rows, and columns. Semi-structured data contains text to clarify how the data is organized. The data is defined by using serialization language. Examples may be HTML, JSON, or XML files. And then unstructured data is least organized. The data is a mix of information that are stored together, but they don't have a strong relation in between. The format of the unstructured data is referred as non-relational. For example, media files, photo videos, Office files, a Word document, PowerPoint, text files, PDF or TXT files can be unstructured data. Let's revisit the recommendation for a solution for storing relational data by selecting a structured data product that matches. If we use the flowchart and have to decide for each scenario to find an appropriate storage option, we probably see our first scenario. You need a globally distributed multi-model database with support of NoSQL choices, and that will kind of bring us to the Cosmos DB database, the Azure Cosmos DB. The second scenario, where we need to have a fully managed, scalable MySQL relational database with high availability and security built-in, no extra cost, we probably will end up with a relational database, but one that has a special flavor here, like Azure Database for MySQL. If we want to achieve something like the third scenario, where we look for, again, a relational database that provides us with quick scale on the fly and includes built-in intelligence and security, we might look into the Azure SQL database at that point. If we need to host an enterprise SQL server, but we want to have the full control about the underlying operating system, we probably end up there with having our SQL server on an Azure virtual machine, or rather have it kind of formalized in infrastructure as a service deployed here. So both these options are valid for that kind of use case. Let's review the recommendations for database and compute offerings in Azure. We mainly find that we have two models that we apply here. An older one, which is the DTU model, on a newer one, which is the vCore model. If you look into the DTU model, we have like 3 tiers available there: basic, standard, premium. And they are all configured with a dedicated allocation of compute resources together with storage, with IOPS that can be provided out of it. It starts with basic, only 5 DTUs. That's a unified measurement that we apply here for these compute, storage, and IOs. And then it goes over to standard. Standard has an offering about different SKUs. It has a range from S0 to S12, which gives you a range of 10 DTUs up to 3,000 DTUs. And the premium tier goes from 125 max DTUs up to 4,000. But the design for the underlying system is differently done. It's high available and has other benefits to offer. If you look into vCore model, that's a little bit like making up clusters of independent compute and storage allocations together. And we probably will find there the provisioned kind of compute, and we also will find a serverless compute. If you look into provision, that's most applicable for databases where we can predict the usage pattern, where we have an simple high average of CPU usage kind of allocated to, and the database cannot tolerate any trade-offs for trimming down or scaling out kind of to additional instances. We can also have multiple database with unpredictable usage pattern consolidated in one elastic pool in that provision model to accommodate a bit to that scenario. If we don't know the usage pattern, we probably look into serverless compute option where we can provision compute and later on make it scale after the workload it sees, where we don't have any history information about the usage pattern or the approximated kind of requests that we see to coming through such a database system. And that's kind of then fitting very well to the serverless compute option in that vCore model. Let's revisit the database scaling strategy a bit more. So if we have to manage and scale multiple Azure SQL databases that have a variety and unpredictable resource requirements, then we will go for the SQL Elastic Pool, which is a scenario in which we can scale with full control about the overall consumption of resources that we have there, but the charge is based on the pool resources rather than on a dedicated usage out of it. So you will pay for the eDTUs or vCores that you use in the pool regardless of the usage for an active hour. If you want to have your database kind of spread out in different regions because you need that for data residency needs or something like that, think about horizontal scaling it by using the sharding provided out of Azure SQL services. And that works best here. So you can then kind of find one database that is the map sharded, which holds some information how the data is sharded across different databases to make the application in a one-stop shop kind of have access to the correct data shard that they are looking for. The last bit that you probably select if you have some dependencies, you want to go into business intelligence and you want to see tools in use or have the result represented in some other tools like Excel, Power BI, Tableau, or Conglass. So then you should look into the Elastic database tools that gives you a capability to query data that is spread out across multiple databases in general. In our example here, we probably then can have the data residing in different databases and have a common query going through that. The query language would be TSQL and can span multiple of these databases. And also these cross-database queries have some aggregation remote table that gives you the opportunity to visualize and communicate them back to the tools that we mentioned here, like Excel, Power BI, and Tableau, and so on. Yeah. So now let's review our data protection. If we look into data protection, we're following the fence and depth model, where we have different layers at which we look into the protection mechanisms that we have. On the network security side, we might find something like a segregation by putting it into different VNets, having it privately accessed with firewall routes and NSGs controlled, or with a private link made privately available for us. Identity and access wise, we can use the Azure Active Directory based authentication, SQL Server authentication, or the Windows integrated authentication as well. In addition, with role-based access control and the predefined roles and permissions, this gives us good steering in the identity and access side of that. If we look into data protection means, the SQL will offer us an always encrypted approach, or even the encryption in use, We might also find something that is protecting in REST data, like the transparent data encryption, TDE, or the encryption in flight, which is the transparent layer security. And we also can use our own keys in such an approach and bring them along. And the additional thing that we have access to is data masquerading. If we look into other additional security methodologies, first and foremost, we see Microsoft Defender for Cloud, Microsoft Defender for Databases, which includes then vulnerability assessment and also some classification of data can be done out of a database system. In addition to the normal SQL audit on the server level, on the database level, we have a good set of information to detect anomalies and malicious things happening in our environment. So let's revisit a recommendation for solution for storing the semi-structured data. So we have there a few things out there. So we probably have a blob orientated solution with Azure Blob Storage, which is kind of giving us an image store, multimedia file store, and blob means binary large object in that kind of regard. We might also use normal file shares if we look for a service that provides that and makes it available to protocols like SMB and NFS. We will find Azure files kind of serving well at that area. If we want to have an optimized blob storage, that is a blob storage for holding this data, we can also use a managed disk approach and also the queue storage and the table storage as services out of a storage account that you can use to hold such unstructured data of different kinds. So queue storage preferable for messages, table storage for some semi-structured data that might exist in a row and column kind of approach without the need to do key usages or joins or foreign key usage. So that's kind of not included in that. So let's go and revisit some solutions for the data storage in regards to the cost and performance to find a good balance. Azure Blob Storage offers access tiers. They are designed for different application usages, and one special account has even a very high performant throughput and a large number of IOPS to offer, which is the premium account of a blob storage. And then we have access tiers coming in, like the hot, cool, and archive one. And the usage scenario should be something you know for. So if you think about hot, it's frequently accessed, it's available immediately, and the data is probably staged to be poured into one of the other tiers over time. So with lifecycle management. If you then look for the cool tier, you probably look for storage for short-term backups, auto media, and you probably don't foresee any frequent use anymore. And then you can apply it. Be aware there is a duration that should be kept on that tier for each file. And then we have the archive tier, which gives us a long-term, very affordable, cost-effective method to hold data, which we don't access. Or we plan to access very kind of few in frequency. At least it should stay for 180 days or more. With that, we have then these different tiers coming at a certain price point and giving us a data solution. Let's compare the data lake storage to an Azure Blob Storage kind of in detail. If we look into that, Azure Data Lake Storage is a specialty. It's a centralized repository for unstructured, semi-structured, and structured data for big data analytics workload usage. If we look into blob storage itself, it's probably optimized for unstructured data of any kind, not only text, also including photos, videos, backup, and so on. The thing that the data lake storage does differently is it uses a namespace, which is a hierarchy namespace, and it's optimized for querying things. So it is even compatible to the Hadoop mechanism. So it's optimized for big data platforms and multi-protocol access, supporting the Hadoop in that. From a security perspective, we can use a variety of user access control list approaches, shared keys, shared access signature, attribute-based access control, and role-based access control, where the blob storage itself is using a flat namespace, not having a support for Hadoop, and kind of uses only a subset of that, like the shared keys, shared access signatures, and the role-based access control. So let's transition over and see what stream analytics can give us here. This is one example of data integration. Data streams are continuously generated from application, IoT devices, sensors, and so on. There is some analytic kind of going on to find some actionable insights, to extract, aggregate certain things with each other, and these kind of data may come from manufacturer equipment, could be simply monitoring telemetry data, of I don't know, something like water pipelines or utility providers. That kind of give us some data streams, and now we want to understand some more out of it. On the other side, we can go with event processing. We can look into events, do analysis on the streams of events coming in, and also there find some actionable items, for example, passing through a toll booth that should include a temporal information, such as a timestamp indicating when it occurred. And Azure Stream Analytics job has some input query output kind of condition. That's probably like something we see there. And of course, we can also visualize such data with Power BI and other means. We can store it for a little bit longer retention in one of the storage options we talked before. And we can also think about using it in form of a data warehouse, and then we need some additional services like Azure Synapse Analytic for training models and do other things with that. Let's answer some practice question about what we discussed in this functional group. Let's now test your preparedness with the practice questions again. It's worth mentioning that the upcoming questions are a bit different from the one in the actual exam. The questions are meant to serve as a review of topics we discussed and to help to give you an idea of the level of knowledge you need to know going through the exam. And remember that the real exam is about applying the knowledge. So the questions are more in the form of a tiny scenario where you will be asked about what you would do in such. For a closer experience on the exam, I strongly encourage you one more time to check out for the official practice assessment. So let's start with the first question here. You have a different section of a database residing in different parts of the world for compliancy concerns. Which database scaling strategy will you use? A. SQL Elastic Pool. B. Horizontal scaling by sharding. C. Elastic Database Tools and Elastic Querying. So it's the horizontal scaling by sharding that will hold the data according to the needs of resiliency in different databases and makes it accessible while that sharding mechanism commonly from the application perspective. Question number 2, you are using an Azure managed instance, Azure SQL managed instance, and you need to design a strategy for protecting the entire database while at rest and require minimum administrative effort to implement. Which solution should you recommend? So we have there the always encrypted, the Azure storage encryption, or the dynamic data masking, or the transparent data encryption. It's a transparent data encryption that gives you the best option here. And with that, let's review and recap what we covered in that functional group. We gave an overview about relational versus non-relational data. We recommend a solution for storing relational data by selecting a structured data product that was matching. Recommended a database compute offering out of what we have in the offer of Azure. We looked for database scaling strategies and data protection means. We recommended a data store solution for non-relational data and balanced out features like performance and cost with each other. We took a look into the comparison of a data lake storage against an Azure Blob Storage, and we took a look into the Azure Stream Analytics.
This brings us to the end of the functional group number 2. We hope you join us in functional group number 3, Design Business Continuity Solutions.